very common question when it comes to continuity is to find the value of a constant, and usually we use the letter k, that makes a piecewise function continuous. So what we're going to do is check the values where the function changes from one function rule to another and see what we need k to be in order for the limit from one side to equal the limit from the other. Let's see this in writing, it'll make a lot more sense. So in order for the function to be continuous at 3, we need f of 3 to exist. Well, that one's easy. F of 3 already exists because we would use the top function rule when x is exactly 3. So it's 3 squared minus 4 times 3 plus 2, which is equal to -1. No problem. Okay. Condition number 1 is check. Great. And to be honest, if you don't write that part, it's fine. The next part is very important for you to write. What we need to do is check the other rule. Make sure that the limit of f of x as x approaches 3 exists. In order to know that that's true, we need to see if the limit of f of x as x approaches 3 from the left needs to equal the limit of f of x as x approaches 3 from the right. And what you need to do is actually write this down. You have to start with this line. And then from there, we're going to keep going. So we will evaluate both sides of that equation as well as we can. And as soon as we get to a point where we have an equation where we can solve for an unknown, that's what we'll do. Okay, so the limit of f of x as x approaches 3 from the left is easy. In fact, I've already done it. We can do direct substitution for that one. It is 9. Right, we can plug the 3 into f of x. If you want, you can write this step down. I would say you don't really have to. The limit of x squared minus 4x plus 2 as x approaches 3 from the left needs to equal the limit as x approaches 3 from the right. We would be following the rule 3k over x plus 2. So we need these two limits to equal each other. To be honest, you can evaluate this step without actually writing down this one, but I think it's helpful to write it down. So the limit of x squared minus 4x plus 2 as x approaches 3 from the left is super easy. We'll just do direct substitution. 3 squared minus 12 plus 2. Here we've already done that. That's -1. The limit of 3k over x plus 2 as x approaches 3 from the right is also super easy. We can do direct substitution for that too. It is 3k over x plus 2 when x is 3 is equal to 5. Notice how I did not plug anything in for k, because we're talking about what happens when x approaches 3, not when k approaches 3. So I'm not going to plug anything in for that k. But now we have an equation with k in it as an unknown, which we can solve for. So multiply both sides by 5. Sorry, that doesn't look right. Equals 3k. And so k has to equal -5/3. And that's our answer. K has to equal -5/3. One quick note is you should check just to make sure that there are no other points of discontinuity to worry about. In this case, we've got a rational function here, and hopefully you remember from Algebra 2 and Pre-Calc that rational functions have breaks, have discontinuities all the time, wherever there are domain restrictions. So take a look at that. X can't equal -2. But that's not a problem for us here, because we're only going to follow that function rule when x is greater than 3 anyway, so we don't have to worry about that -2. It doesn't cause us a problem. We don't need to say anything about it. It's worth making a quick check there. So our answer is that k is equal to -5/3. And one thing we can do is run a quick check in Desmos on this. So what I'll do is type this into Desmos. And if you don't remember how to type in piecewise functions in Desmos, that's okay. But the one difference between writing it into Desmos and writing it by hand is we put the function rule first. Sorry, the subdomain rule first. X is less than or equal to 3. So when x is less than or equal to 3, the function rule is x squared minus 4x plus 2. And then for the next function rule, we put a comma, and then we'll write the subdomain. As long as x is greater than 3, we'll follow the rule 3k over 3k over x plus 2. And they're going to ask me to add a slider for k, so I'll do that. And you can see that when I change the value of k, oh, sorry, that should be a colon, not a comma. When I change the value of k, you can see the function eventually can become continuous. And we're looking for x is equal to negative 5/3, which is right around there. I'll type it in exactly as we have it, negative 5/3. And you can see that that does make it for a continuous function. We can zoom in all we want there. You can see this function is continuous right there.